Hey everybody, this is MoBaller12 here to help quench that knowledge thirst. I know it's been a while, so please forgive me, but I've been really busy, and hopefully in the near future, once the dust settles, I'll let you guys know what I've been doing. But meanwhile, I want to talk a little bit about the goal of this channel. So I'm gonna start uploading more videos starting now. This first video is going to be on a physics topic, believe it or not, and it's on work. I had an individual on my Facebook fan page request me to make a video on work, and so I decided to go ahead and make that video. But before I go any further, I want to just stop a second and discuss something, okay? That term I used, fan page, I think it's a derogatory term, okay? I don't think of you guys as my fans or whatever. I don't think of it as a fan page, even though I've said it many times in my other videos. But I don't think of you guys as that. I think of you guys as my students, rather as my friends. Even though I haven't met you guys, but I'll still consider you guys as my friends. But nonetheless, I don't like that term fan page. That's not the goal of this channel. This channel is not for me to get famous off it or do anything like that. It's meant to just provide help. I love teaching, and I show my love for teaching by making these videos, okay? And that's it. I just love doing it. I love doing these videos, and that's why I upload these videos, just to help you guys out. So that's that. So don't think of it I'm trying to get famous off this, or making money off this, because that's not the case. I'm doing this because I enjoy teaching. It's a passion of mine. Whenever I have time, it's like a hobby. I enjoy doing it. So that's why I make these videos, just to help you guys out. So that's that, okay? So don't think of it as fans or fan page or anything like that. I think of you guys as my students, okay? So that's enough of that sentimental stuff, okay? I don't want to get any more emotions to this video, because that's not the case. So let's start talking about this topic, which is work, okay? So how I'm going to structure this video is I'm going to define what work is, show you guys the formulas, do 3 examples, and call it a day, okay? So without further ado, let's get right into it, okay? So work, what is work, okay? Work is basically, I'm just going to talk about it for a second. I'm not going to write anything down. Work is basically, when an object moves in a certain direction due to a force that's applied. Okay, so when a force is being applied onto an object, it moves in a certain direction. Okay, so if I want to draw it out, excuse me. So here we have a box. A force is being applied. Pulling force, pushing force, doesn't matter. A force is being applied, and it moves in this direction here. Let's just say it moves for 10 meters or what have you. 10 meters. That is basically what work is. It's a force being applied onto an object, and that object moving in a certain direction. Okay, and that's how work is calculated. So that's the basic concept behind work. Now, work and energy have some relationships. Work and obviously force have relationships, and that's what we'll focus on. But there's a lot of relationships found in physics, okay? So let's get right into it. So there's 2 formulas that you should be familiar with, but essentially they're exactly the same thing. So work equals the force parallel to the distance or displacement, or work equals the force also parallel, so it doesn't change, but what I'll do is I'm going to erase that for now, times cosine theta times the distance. Okay, so again, W represents work, F represents force, D represents displacement. The same thing applies here: work, force, displacement, or distance. This theta, this angle, is where a lot of students get confused, okay? Theta, okay? So let's expand a little bit on theta. I'm gonna write a little bit about it. So theta equals angle made between the direction the object is moving and the force of interest. Okay? So that's what theta is. So the angle made between the direction the object is moving and the force of interest. So for example, if we have this object that's resting on top of the ground and the object is moving this direction, but the force we're focusing on is the force of normal, for example, well, the angle made between these two things, if this is the direction, so say that the object is moving this way, this is not a force, this arrow is just moving this way, the angle is 90-degree angle, so that's what you'll plug in there, 90. Now if the force we're focusing on is this way, the force of friction, for example, say the object is moving this way and there's a force of friction in the opposite direction, the angle now would be 180 degrees. That should make sense. Basic trig or geometry, whatever you want to talk about, but nonetheless basic, I think it's geometry, that's where they talk about angles and all that good stuff. So trig, I think, has to do more with cosines and stuff like that, but nonetheless the angles you guys should be familiar with. And again, if the force is this way, okay, you can select, it could also be 90 from this way, or it could be 270, what have you. Doesn't really make a difference, it'll come out the same way, but nonetheless that's how you determine theta. Okay, so that's it for theta. Okay, let's talk about the units. So work, its units will be newtons meter. As you guys know, units is extremely important in terms of in the field of physics, so make sure that you have your right units. Force will be in terms of newtons, distance will be in terms of meter. Essentially, when you multiply these two together, you get the Newton meter. Same thing applies here, so this is going to be newtons. Angle has no units. Theta, distance again would be meter, so when you multiply all this together, you get the Newton meter. So that's that. Those are the two formulas. They're exactly the same thing, except that in certain cases you want to use this formula, in certain cases you want to use this formula. And it's pretty straightforward when you want to use this formula, when you want to use each formula. When the question presents an angle, obviously you want to use this formula. When it's a very basic, straightforward problem, you want to use this formula. So let's get into some examples, okay? I have 3 examples for you. I hope this video doesn't take more than 15 minutes, but if it does, you know, oh well. So the first problem is you have a car. So example 1, car pushed with force of 100 newtons for 10 meters. Car pushed with a force of 100 newtons for 10 meters. How much work? How much work has been done on the car? Okay, here's your car. It's moving. It's a good-looking car, I must say, but nonetheless, it's a car that's being pushed in this direction. So force of push, right, which equals 100 newtons. It's being applied in a certain direction. Well, obviously, I just picked my own directions. Okay, I could have said a car pushed to the right with a force of 100 newtons, so I could just clarify it better. Car pushed to right. Car pushed to the right. I'm making the question very, straightforward, so we don't have all that verbiage and all that extra words in there. So car pushed to the right for 10 meters. Okay, so we know the force applied. We know the distance. So let's use the formula that does not have the angle, even though we could use it, but let's avoid it. So the formula is work equals force times distance, right? Let's write down our givens. That's the way you want to approach these problems. Write down all your givens. So the force equals 100 newtons. Distance equals 10 meters. So work equals, the force is 100 newtons. Distance is 10 meters. So work equals 1,000 Newton meter. Voila. Very straightforward, very easy. Let's not make it more complicated than it should be, okay? Next example. Okay, example number 2. What are we at? 9 minutes? I gotta hurry up. I don't want to make this video long. So I have just a bunch of problems I came up with. So example 2, car pushed to the right at an angle of 30 degrees with respect to the ground. Okay, I'm gonna write it out, but assume I wrote out with respect to the ground. Okay, let me I'm messing up, I'm not even showing you the question. So car pushed to the right at an angle of 30 degrees with respect to the ground, with a force of 100 newtons for 20 meters. What is the work? Okay, sorry about that, I'm getting some text right now. But nonetheless, what is the work done? Okay, so let's write out a formula. Since we're dealing with an angle, we're going to use the work formula that has that angle in it. So work equals force cosine theta times distance. So work, first before we get into writing out, plugging in, chugging, let's write out our givens. So force equals 100 newtons. Let's see. Theta equals 30 degrees. Let's see. Displacement or distance equals 20 meters. Okay. So work equals the force, which is 100. So I use distance and displacement. The term you want to use is displacement. Okay. I use them interchangeably, but you want to use displacement. It's the distance moved from the initial to the final position, okay, for the object. Okay, so 100 newtons cosine, let's get back to the problem, 30 times distance, which is 20, or displacement, I'm sorry. The work, let me plug it into my calculator, so I haven't solved this problem. Hold on one second. Calculator. So option cosine 30, come on, okay, times it by 20, times it by 100. I got a value, so you guys plug it into your calculator, check if I made a mistake or not, but I got a value of 1732.05 newtons meter. Okay, so there you go, there you have it. Okay, so that's example number 2. Next, let's get to the next problem. So make sure that that's correct. Okay, let me know if I got this incorrect, because I'm going fast on my calculator. So this should be really straightforward. Don't make it complicated, because it should not be complicated. Okay,